All right, you guys, still in the first lesson of the unit, explaining volume. This is slide 16, which is volume formulas, volume of a cone. All right, so let's see. You compare the volume of the cone to the volume of a cylinder with the same base and height as the cone to find how their volumes are related. I already know this what's going to happen here. So if you really want to know what's happening, I'm going to attach a video with this class doing a little popcorn activity where they fill up a cone and a cylinder. Watch that video, and especially you visual people, it'll explain how they are related. Okay, so I'm going to open up both of these, it looks like. All right, so there's my cylinder. Open up volume of cone. Okay, there's my cone. All right, so drag the orange points of the cylinder and the cone to change their radii and heights. Make sure the freeze height check boxes are not checked. Set equal radii and heights for the cylinder and the cone and note their respective formulas. Record the volumes of the few sets of heights and radii. Okay, so I need them to be the same first. So I got a radius of 12, height of 14, radius of 12, height of 14. So I'm going to use what they've got so far because they're both the same. All right, so radius 12, height 14. All right, I'm looking for the volume of the cone, which is right up here, 2,111.2. I need the volume of the cylinder, 6,333.45. 6,333.45. Now, ratio means we're going to be dividing these. And I want you to notice that when the radius was 12 and height was 16 for their example, you got a volume of 0.33. And I guarantee you that we're going to have the exact same thing here, but I am going to divide them. So we're going to divide the cone by the cylinder. So I'm going to take my cone, that 2,111.2. I'm going to divide by the cylinder, which is the 6,000 number, 6,333.45, and we're going to get 0.3333, and I'll just kind of stop it there. So if you've already watched that video of the popcorn kernels, you know it takes 3 of these cones to make one cylinder. That's why they're 33% on each one, or 33.3% on each one. All right, we'll just do one more and make sure you understand. But watch that video, okay? All right, so let's change this radius. Let's change it to a 10. I'm going to keep the 14. Change this radius to a 10. And I'm going to keep the 14. Yeah, okay. So I got a radius of 10. I'm going to keep the 14. All right, volume of the cone, 1466.1. The volume of the cylinder, 4398.23. 4398.23. And when I divide them, cone by cylinder, I'm going to get 1/3. 1466.1 divided by 4398.23. And yep, there it is, 0.33333. So basically what you need to learn from this is it takes 3 cones to make a cylinder. 3 cones to make a cylinder. And for you visual people, watch that video and you'll see how that works. All right, so I'm going to go ahead and submit this because of time. You guys get it. All right, question 2. Based on your results in question 1, how is the volume of the cone related to the volume of the cylinder, given that their bases and heights are the same? Keep in mind the volumes you recorded were rounded, not exact values. Okay, here's what you need to know. It takes 3 cones of the same dimensions to be one cylinder. That's why when you divide them, you always get 1/3 because it takes 3 of them. All right, the ratio is the same. That's what I mean by dimensions. The volume is 1/3. All right, there you go. questions, my 5. All right, so listen, that was how the volume of a cone and cylinder are related. So let's see what's coming up next.